My name is Brad Fessler. I'm the professional development manager here, and so it's good to be on here again for eCoach Day. And today we're going to do some IR communications. So bear with me. I'm not in my normal environment here. I'm actually working remotely today. So bear with me as I kind of juggle a couple things at the same time here. But I'm going to start by sharing my screen here. And let's do.
Sorry, my cat's deciding to join us.
Oh, perfect. Love to have some guests. All right. As I mentioned, my name is Brad Fessler. Here's my contact info. So if any point in time you need help with one of these things, feel free to reach out with anything we've discussed. I'll be glad to help you out. So with IR communications, we actually can communicate between multiple robots in this case. So we are going to communicate using Rover and Bolt here. So getting connected to Rover is a very similar process. However, it's actually easier to be super precise when you connect to Rover. If you flip Rover upside down and look at the bottom, there's actually a connection code there on the bottom of it. So it makes it super easy to connect to the exact one you want. You don't necessarily have to use the Harry Potter method like we do with Bolt. So just an option to get you started there. And some of the unique features that are there with Rover, it has a color sensor on the bottom. So if you're familiar with Sphero Edu, which is designed for our younger learners, you actually have the ability to use that color sensor to program Rover in a very similar way Indy behaves, where it uses that color sensor, it sees something, and then does a command. Only now you get to control what those commands are. And you actually get to pick the color as well, which is really pretty cool. Another thing that's unique to Rover is we have a drive to distance block. So you can actually say, I want Rover to travel X number of centimeters, and Rover will travel that distance. Unlike Bolt, where you have to kind of experiment with speed and time to go a certain distance, here you're able to actually set that distance in a block, ready to go. The other thing that's really cool about Rover is it allows you to build on top of it using third-party hardware, things like Littlebits, Microbit, and even Raspberry Pi. So your connections here are USB and a UART port. So it's really cool to be able to, interface with Rover using those different things. So for instance, when you use Microbit, like what's pictured here in this graphic, you plug in USB. Rover actually powers the microbit, so you don't have to worry about another power supply or anything like that. Plugs right in, and then you would program Rover using MakeCode and an extension inside of MakeCode. So kind of cool. Gives you some options to play around with here to be able to build out some really, really cool options here. So let's.
Brad, can I just interject really quickly?
Sure.
The three folks that are with us in the session are all middle school, so they have access to bolts. They may not actually even know what RVR is. So I just want to pause for a moment and either I can give them a little background on RVR, or you can give them a little background on Rover or RVR as it's known, just so that they kind of understand. And then Leslie had asked, is this session going to be primarily about RVR? Because again, what they have access to in their schools is the Bolt robot. I think Leslie actually may have one or more RVRs, but I don't know that anybody else.
No, I'm afraid not.
You don't. Okay. I thought you and I had a conversation about that. But Brad, do you want to give them just a little quick overview of what RVR actually is?
Yeah, so absolutely. So just FYI, the session can be done with bolts as well, not just Rover that way. So you can actually do the same thing using 2 bolts or two rovers or a rover and a bolt. It doesn't matter how you're actually working with this. Rover is just kind of a tank drive development platform. So it's coded the exact same way in Sphero Edu as Bolt or Mini for that matter. It just has those few unique features that I mentioned earlier that take it a little bit to a different level. So this is kind of like that middle school moving into high school level, depending on how technical you want to get. So when you start adding third-party hardware on here, then you kind of level up the ability of the students to be able to build some really cool inventions and then get them on the move using Rover. So it's just another way to do this. For our instance here today, you actually don't need to use Rover. You can use a Bolt to do this same thing.
And just one last, I hope, last interjection. All of our high schools are actually receiving the Rover. So, so as you guys work on any activities with your kids with their bolts, know that you're helping to level them up for what they might experience when they get to their high schools and they have access to that RVR or Rover robot.
Yeah, yeah, and I think that's where the request was made to like include Rover in the presentation. So I'm glad to hear that we're kind of leveling some things up. That's awesome. All right, so some kind of activities that you can do, just like what you would do with Bolt. Since we don't have any on hand right now to do this, we'll just talk about it. So you can do like use that roll to distance block instead of a roll block. So again, this allows you to set a precise distance to move, and then you can experiment with different speeds with this. Rover is a really capable robot, so it can go over some really rough terrain. It can also move very precisely when it's on a smooth surface. So it just kind of changes the equation when you're coding some different things. One of the things that we would experiment here in this particular challenge is the drive to distance block has a set max speed setting. So unlike a roll block where you set a speed and that's the speed it's going to move, the drive to distance block, you set a maximum speed, and Rover will try to achieve that speed over the distance that it needs to move. However, if you set like a really short distance and you set your speed to the maximum speed, it's never actually going to hit that max speed, like that 255 setting, because it doesn't have enough time to accelerate to that and then decelerate to that. So just kind of a cool challenge when you're dealing with Rover. So now we'll get to the Bolt portion of this. Again, best practices for connecting using that Harry Potter method of being able to you know, search for robots, pick one randomly out of that list, it will light up in the case, grab it, and you're off and running. Also, don't forget that you have the ability to use the Find My Robot feature, which is available on macOS, iOS, and Android devices, including Chromebooks. So that's out there. You can turn that on. It just helps in identifying which robot you are connected to. Don't forget about aiming when you go to run your programs. It is important to aim that robot so you know which way is 0 degrees. So in this case, we want to experiment with infrared communications. So we're going to send that information specifically using light, infrared light, using Bolt. And the cool part here is, again, this works between robots. So it could be Bolt to Bolt, it could be Bolt to Rover, it could be Rover to Bolt. And actually, if you use the trigger bit in little bits, you can actually send from Rover or Bolt to little bits. Note that you cannot send from little bits to the other robots, but it does give you the ability to interact between all these different kinds of products to make some really, really cool and creative kinds of inventions. So a couple things to think about with infrared is it is light. So it is direct line of sight. So this is not going to work through a wall or around a corner, things like that. The way I equate this is, growing up in Pennsylvania, those wonderful cold winters that we get there. I'm laying on the couch, watching TV, and it's cold, and I don't want to change the channel on my TV because then I got to stick my arm out from under the blanket, right, to make that press that button on the remote so that the signal can get there. It's that same kind of concept. Good news is TV manufacturers have caught on to that, right? And now a lot of TV remotes are Bluetooth, so you can stay curled up under that blanket and still use the remote. Our robots are using infrared to send these signals, so it is direct line of sight. Also, something to note that as you're setting up your channels here, it is possible to send a signal from one robot and affect a whole bunch of other robots if they are coded to send to do something when they receive that message. So what do those blocks look like in Sphero Edu? The first one is broadcast, and this sends a constant signal on two channels at the same time. So when we're looking at this particular block, you'll see it's channels 0 and 1, channels 2 and 3, right? And when you activate this in your code, it broadcasts out constantly until you tell it to stop broadcasting. So there's another block that says stop broadcasting, and until you activate that block or stop your program, it's going to continuously send that signal. And what that allows you to do is, one, you could trigger a little bit circuit to just stay on during that time, or you can use the next two blocks, which are follow and evade. And what this does is it follows the signal on the channels that you specify. So the robot will literally follow that signal, or it'll evade that signal. So it's actually kind of funny. We see teachers use this where like they turn their robot on to broadcast and then they walk, and everyone else's robots are set to follow, and then everyone else's robots just follow that teacher as they're walking around the room with that broadcasting robot. So it's actually really pretty cool. You can get them to follow each other or run away from each other, and you can come up with some really pretty interesting games. We've seen people program Pac-Man, right? And being able to follow things or evade things that way. It's really pretty fun. The next one is send a message. And this allows you to send a quick pulse of a signal on a very specific channel. So these robots can broadcast on 8 channels, 0 through 7, and you can pick the intensity of the signal, anywhere from 1 to 64. 64 being the strongest signal, and ranging all the way down to barely any signal. So as you adjust that range, that intensity, it's going to adjust how sensitive the other robots would be seeing that signal, right? So if they're further away, if a robot's kind of far away and you set it to a signal intensity of 5, that other robot may not get that signal, which could be by design or maybe be a bug in your code and you have to adjust that. And then since we're sending out a message, we need to be able to receive a message. So that's the next block, and you'll see that block is a different color. That's actually an on event block. So here on message received, anything that's attached to this on message receive will execute in your code when it receives a message on that specific channel. So do note that since you're controlling 2 robots here, you would need 2 programming devices when you do this. So just something to keep in mind as you're kind of working through these. You have 2 robots, 2 programming devices, 2 separate sets of code. So that's really, really important when you're doing this kind of an activity. So here's an example of an activity, and down in the lower right corner we have that activity code that's there. 74216. We are not going to do this activity today, but this is a great example, a really fun one. This is great if you're doing like a review activity for students and you want to kind of turn it into a game, right? So what you'll use is you need at least 3 bolts when you do this particular activity. However, you can do up to 8 bolts in this activity. One of those bolts is the game host. So think about this as the game show host that's there, right? So it's the person standing up, kind of directing the flow of the game. That's the host bolt. This is the one that's going to receive infrared signals from all of the other bolts and then prompt that team that it's their turn to answer the question. The other bolts are all going to be buzzers. So think a game show buzzer, right? The question's asked, the participants have to slap that buzzer, right? The first one that slaps the buzzer gets to answer the question. So how do we determine who slapped the buzzer first? Well, that's what our code does. So it allows you to do some really cool things there. Couple things to keep in mind when you're doing this. Remember, it's line of sight. So the game host bolt needs to kind of be in the middle of the room, right? It's as equal distance as, you can reasonably do. You don't have to get a tape measure out or anything like that. Kind of get them somewhat equal distance away around the room and make sure that there's a clear line of sight, that there's nothing in between them. When you do this, each team that slaps that bolt, it will broadcast a signal out, and the game host will grab that signal, and whichever one gets there first, that's the one that the host will announce and change that color, and they get to answer the question. It's actually a really cool activity. So check out that activity code when you get some time. Just a cool use of this in particular. Don't worry, this slide shows broadcasting between Bolt and Rover. Again, you can do this between Bolt and Bolt, so it does not matter which one is there. So anything that says Rover Plus in here, feel free to substitute Bolt into that, and it will do the same thing. So here's your challenge that we're going to work on, is you're going to be able to shake Bolt. So you're going to use that on collision event, and that's going to send an infrared message to your other bolt, and that bolt will move in a pattern, right? So in this case, we're going to do a hexagon, and that allows us to talk about some more advanced movements here in that hexagon shape. So we'll look at how we can do some cool shapes with Bolt, not just using roll blocks to do that. So down at the very bottom of the screen, there's that little asterisk there that says an advanced challenge. That's what we're going to do today. We're going to do that advanced challenge. We're going to trigger this to happen by sending a message. So let's take a look at Sphero Edu, and we are going to, I'm going to write this both programs on one screen so you can see this, but FYI, if you're doing this and playing along here at home, make sure that you're actually using 2 separate devices, one for each robot. So I'm going to create a new program, and I'm going to call this IR transmitter, and I'm going to do block coding, and I'm going to do Sphero Bolt. I'm going to hit create here, and now I'm ready to send a signal to my other bolt. So the way this will work is I want to do this when, just slide some things out of the way here so I can see all my buttons, when I shake my bolt. So I'm going to go to events, and I'm going to choose on collision. So that means when I shake bolt, it's going to do this. Very simply, I am going to send a message, and see if I can zoom in there and make that a little more friendly to be able to see. And you can see we have channels 0 through 7, so 8 different unique channels. You pick your channel that you want to send on. Does not matter which one. If you're doing this in a classroom full of students, you want to make sure you assign a channel to a group. Otherwise, they're going to all kind of be blasting signals around the room, and other people's robots are going to be responding to other students' signals. So we want to just make sure we kind of make our lives easier as a teacher and say, all right, you're group 0, you're group 1, and let them make sure they work on their particular signal. Then we have that value 1 through 64. Since I only have 2 robots here in my room and I don't have to worry about, you know, how far I blast that signal here, I'm going to crank this thing up. I'm going to go to 64. That's going to give me the strongest intensity out there. Would I really need to go to 64? Probably not. I could turn it down here. I'm in a fairly small room. So I don't need all of that signal strength to be able to reach the other robot. Again, kind of subjective. You want to play around with this, do some iteration to see what you get to work there. All right, so this is our simple code to send a message, right? This is it. We don't have to do anything else if we don't want to. I know if you've been on any of my sessions before, I'm a big feedback person, so I like to give feedback to my user. So I like to just let my user know, hey, we're ready. We're gonna send a signal. We're ready to do this. I'm gonna put a green LED there on start so that I know my program's actually running. So this is my first code for the transmit part. Now, on a different device connected to a different robot, you would then write the program to receive this. So I'm going to jump to a different program here. I'm going to go under IR receiver. I'm going to already have one. Oh, maybe not. There we go. I'll just make a new one. That works. And there we go. Now, under events, I'm going to choose on message received. And what this allows me to do is now program what I want to happen when Bolt gets this message. So again, make sure you select the correct channel for what you're going to be broadcasting. Since I was broadcasting on channel 0 earlier, I want to make sure that when my robot receives on channel 0, it does this. Do note that you can send a message on different channels. So you could have a robot that sends 8 different messages and a different robot that does 8 different things every time it sees a message on that particular channel. So you can actually do all kinds of really cool stuff. You can have them send messages back and forth even. So however you are creative in applying this, you can do some really, really cool stuff. So if we remember, our challenge here was to get our Bolt, when it receives the signal, to move in a hexagon. So let's talk about the movement part of this. So under our movements category, we could do a roll block, and we could do 6 different roll blocks, right? And we could put our heading in for each angle. So great math application here for students is, if I'm doing a hexagon, I have 360 degrees in my shape. I have 6 sides to that shape. So if I take 360 divided by the number of sides, in this case 6, I get 60 degrees. So that's how much my heading would need to change. If I'm doing a square, right, it would be 90 degrees. If I'm doing an octagon, it would be 45 degrees. So you can really do some cool shapes like that just by doing a bunch of roll blocks. So that's really cool that you can do roll blocks and make all those adjustments. But let's think about leveling up our code here a little bit. What if we could do this shape in a loop so that we only need maybe one roll block, or we don't use any roll blocks and we use the individual components of that roll block. So a roll block is heading, a speed, and a time. So we could go in here and we could say, all right, I have a heading, I have my speed, time is controlled by a delay, and then at the end of a roll block, our robot stops, right? So this is the exact same thing an empty roll block is. So if I set my speed here, say I'm going to set mine to 100. Since I'm on carpet, I need to set it a little higher to get it moving. And I'm going to have it roll for 3 seconds. So now I have a roll block. My robot, just like this, would go straight ahead, speed of 100 for 3 seconds, and then it's going to stop. But I want to do this multiple times. So I'm going to go under controls, and I'm going to do loop number of times. So I'm going to put that around my, as we call it, a deconstructed roll block. And there's 6 sides to my hexagon. So I'm going to do this loop 6 times. There's one issue to this right now. And if we just run this code, what will happen is Bolt will drive straight forward at 0 degrees at a speed of 100 for 3 seconds 6 times. It's just going to keep doing it. We need to do some math for our heading here. The way we do that, we go under operators and we grab that 0 plus 0 operator. And then we go under sensors and we can grab the heading sensor and drop it into our operator. Now I can take this whole operator block and drop it into heading. So the way this reads right now is our new heading is equal to our current heading plus whatever number we type into here. In this case, we're doing a hexagon, 60 degrees. So every time this loop runs, it's going to take our current heading, add 60 degrees, drive forward at a speed, or drive that heading at a speed of 100 for 3 seconds, stop, and repeat. And it'll do that 6 times over and over. Now, if you remember when we do things like programming a square and we're using multiple roll blocks, we need to add one more delay here. We want to make sure that the robot has enough time to come to a complete stop. So I'm going to put a 1 second delay after my stop. Now this needs to be attached to something. So I'm going to attach it to on message received. And now I'm actually able to run this. So I can hit start here. I got to connect to my robot. And now I'm set up for my robot. And I'm going to hit start on my other programming device for my on collision here. I'm going to give my robot a shake. And when I give my robot a shake, my other bolt is going to start moving. There we go. Open. It's running into everything in my room here. So we're going to see it draw out my hexagon, minus that it ran into all kinds of stuff. So it's struggling to make that actually a real hexagon. So I could alter my code to maybe make this a little bit smaller so that I'm not running into things, right? So if I want to make this a little smaller, I can do less time or less speed. I'm on a kind of a textured carpet here, so I probably need to keep my speed up here. And I'm just going to drive my robot back over here so that it's somewhat close to me and you have a little bit of room. And I'm going to aim my robot. There we go. And let's try that again. Let's see where we get. Still a really big hexagon for a small room that I'm in, but you get the idea of how this will actually travel. I ran into a bunch of stuff here, so it's even looking less like a hexagon right now. So the cool part with this is it really gives us some options to do those communications kind of things. Do we need to be able to drive a specific shape? No, we can do other things like we could flash lights, we could have it show a message or scroll text or do different things like that. We want to change our shape here. We can easily just change the number of loops. So let's make this a square. So 360 divided by 4, it's going to give me 90. Now I'm doing a square. So quick and easy ways to make those changes and get your robots moving and communicating. All right. So let me see if I can get back over here. There you go. When we're doing this kind of thing, don't forget to add some style, add some lights, add some sounds. We want our students to, have that creative freedom here when they're programming and really get a chance to explore some of the different options that the robot can do and, explore their own style with things. This could also be done using a roll block. So let's take a look at how we can use a single roll block in a loop to do the same kind of thing. So instead of doing the deconstructed part here, if I go under movements, I can bring a roll block into here and I can take this heading and I can drop that into my heading in the roll block. And now I can set that speed. And I'm going to attempt to make mine just a little bit smaller here. And this uses way less blocks and does the exact same thing. So you're like, Brad, why would I ever want to make this more complicated, right? So when you're trying to explain to your students like how this thing kind of works, so how does a roll block work? What are the individual components of the roll block? Seeing them in the separate components here can be super, super helpful for the students to kind of picture, how does this thing work? Well, we've set a heading, we've then given it a speed, we've then told it how long to drive, and then it actually has to stop. So again, I lost connection here because I left my program. All right, and I'm going to run that again. And I'm going to shake my other bolt. And it is sending that signal. I got a little more of a rectangle here than I did a square because, again, I'm running into all kinds of things in my space that I'm in here. Okay. Stop sharing. All right. Who has questions about how to make those IR signals work?
I know the number one question placed in the chat was whether or not you have written directions for all of this.
Yeah, so great question. There are activities that are used for teaching infrared that are out there. So if you search under inside of edu.sphero.com for infrared, you can find all kinds of cool activities there. So let me actually, let me get to the right page here. So edu.sphero.com. And if you go under activities, right, and go under the Sphero activities, under this filter funnel, I personally like to use the filters versus search. I think it gives you a wider range of results. You can go under tags and you can find there's all kinds of different tags that are in here. And you can do some, you can find all kinds of different things that way. If there's not a tag for what you're looking for, so like in here, we don't have infrared tag, right? You can use the search and actually search through here. So if I search IR.
Brad, you're not sharing your screen with you, with us. I don't know if you meant to be.
Yep. Give me 1 second here. It's actually not letting me do that.
Your inventory.
Yeah, I don't see where the search key button is.
Yeah, give me 1 second here. There we go. Is there we go. Okay. Now we hopefully have
Yep,
the same.
you're coming up now. Yeah, we can see you.
Perfect. So if I go in here and I just search like communications, right? I'll start typing that in. Right here's one that's all about infrared communications. There's actually a bunch of other ones that are out there as well. In this particular activity, it teaches almost the same thing that we just went through of being able to look at getting another robot moving by sending a message, right? In this case, here in this first part, they're looking at sending that message every half second. So that's kind of cool. Then on the other side, it has the other robot that's receiving that message, right? They can get it moving based on what that message is that it receives. So they walk through all of these steps on how to actually get them communicating, doing what that is, setting those up, dealing with those two different kinds of programs and robots there. And this particular one, that activity code, and let me make this a little bit bigger so it shows up in the recording better. This activity code right here, 60256 is this particular one. And this will get you started on how to set up those two different programs to get them communicating.
Go ahead and click on my link here and share with
All right. Great question.
I searched virtual field trips.
Okay. What other questions?
So I favorited it.
Oh.
And so it's in my favorite section and also in my profile. But as
Yeah, go ahead, Joe.
give you a lot of
So this is a new experience for me, and I teach social studies, and I had to ask where I would even have these in our building. And apparently science has it, and then the media center has it. How can I make this applicable to social studies?
Yeah, great question. So think about communications, right? So you can look at the history of communications, right? In this, it doesn't necessarily have to be infrared, but think about how we've communicated over the years, right? So we originally delivered messages, depends how far you want to go back, right? if we're looking at US history, we delivered messages via horse, right? Then we delivered them via vehicle and airplane, right? And now we deliver them instantly, right, through telecommunications and the internet. So how can we simulate those different things in there? Add a delay, right? So now if we're comparing those, if I'm sending a message via horse, my delay is going to be days, weeks, right, to get that message from one place to another, versus I'm sending it the other extreme digitally, just like we are now, right? I can put no delay in there and it's instantaneous when it gets there. So you can start looking at those history of the communications technologies that were out there and actually simulate those. So let's look at how we can tie that into each group. Okay, you're going to communicate, you're going to simulate communicating via horse. You're going to simulate sending a communication via an automobile. And now here the internet, right? And then they can compare what are those results. They have to think about how that works. So great question. All right, let me see. There was another one that also...
Leslie had her hand up a moment ago, but then she lowered it. So I don't know if maybe it was similar to Jill's question and she was looking for applications. And then Teresa, Ms. Nelson had placed one in the chat. So Leslie, if you still have a question, I'll let you go first and then we'll tackle the one that was placed in the chat.
Yeah. Hi.
Hi.
Hi. We tried to do the Sphero Bolt mission challenge recently, and one of our difficulties is that our bolts aren't that precise. We had to do a lot of trial and error to go to a precise location on the grid that we were trying to do.
Yep.
And that is very difficult for my kids, because we would write these lovely programs and one time it would work and the very next time it would crash. So I just wondered if you have any tips.
Yeah, so some tips on that. Try to slow your speed down a little bit. The higher the speed is, the less precise bolt is going to be, right? Because there's a little bit of physics that has to happen there, right? The speeding up and the slowing down portion, the higher the speed is, the longer that acceleration and deceleration will take, and that can really kind of start to become inconsistent when you crank that speed up. So if you're on a smooth surface, keep those speeds lower. If you're on like a carpeted surface, like the carpet that's here in the room I'm in right now is like a textured carpet, I'm never going to be precise on a textured carpet like this, right? It's just because it's going to bounce around. You probably saw in my data when I was doing that demo, it's bouncing around, it's bouncing into things, right? Make sure it has a clear path, as smooth as a surface you can work on when it comes to that will help with precision. Slow things down and add delays between movement blocks. That's the other part, is make sure that the robot truly comes to a complete stop, even if it sits there for a second, and then execute the next roll block. But slowing things down, adding that delay in between will really go far to help with that precision.
Yeah, thank you. That I should have remembered that from science class last year. We used the Spheros for some activities, or at least I saw Miss McKenna do it with her classes, and she definitely built in like turn, like roll, stop, then turn, then roll.
Yep.
So it was for that reason, I'm sure.
Yeah, make sure you use the delay block under controls, because that allows for the time to take place where nothing
versus the stop.
Not stop. You want to use delay. And delay is under the controls category.
Yeah, I found the delay, but why not stop? Just curious.
So at the end of a roll block, there's actually a stop built into the roll block. So stop is just a command to come to a stop, but you have to allow time for the physics of that to actually happen.
Got it.
Where the delay comes in to allow time for the real world to take place, right? Because otherwise your coding device is going to read a line of code, do it, and immediately read the next line of code, do it. So if we tell the robot to stop, but then read the next command, which is move, it's not yet completely stopped.
Got it. That makes perfect sense.
Yep.
Thank
Yep.
you.
Great. Yeah, great question. Great question.
And I'll just share this with the others in the group that they, like in science, they did something really fun where they were learning about waves. And so they had the bots travel through paint.
Yeah.
And then draw a wave. And so it was pretty cool. They learned about amplitude and all this stuff, you know?
Yeah. There's actually a waveforms activity that's in Sphero Edu and maybe that's what they were doing.
Maybe.
But it actually talks about the lessons of waveforms, and being able to illustrate that not only in the data that you get back from the robot, but by doing things like rolling through paint, or if you put a cup over top of the robot. So if you take the robot, set a cup on top of this, a 16 to 18 ounce plastic cup, 2 rubber bands, and a marker, and you're off and running to be able to draw whatever you want that way. We do recommend trying to make sure they stay contained, you know, so that they're not drawing all over your floor. We want them to draw on the surface you want them to draw on. So we've seen some really cool creative ways to do that. PVC pipe, pool noodles. I saw a really good one. If you're on a carpeted surface, they took like pieces of wood, like a 1x1 piece of wood, and they put Velcro on it so that it would stick to the carpet, right? To help contain the robot so that they're not running all over the place and drawing or painting on things you don't want them to be doing that on.
Open up a pizza box.
Yeah, right. Whatever it is that you want to do, just make sure it stays contained.
Well, the other thing that I keep playing around with the idea of is storytelling. I think that one of the ideas of using bots is that you can demonstrate learning by having your bots like maybe travel a timeline and stop and speak or something like that. Like the speaking is, can you talk about what kind of speaking it can do? I know it doesn't have any speakers in it, but your device will broadcast something. Is that a computer voice reading off what you type, or is it your own voice?
So great question. And I'm gonna change what I'm presenting here so we can see it. Let me see. Oops, I gotta get to the right window. There we go. So when we're dealing with the sounds category, we can play a sound. There's a whole bunch of libraries in there of different sounds, but the speak command that you're talking about here, this speak block, allows you to type things into it directly. So the programming device will speak whatever it is that you type into here. Okay, I'll say that again just so we're clear. It will speak whatever you type into there.
I hear you now.
Yeah. The only time it will not speak certain words is if those words are removed from the dictionary of the programming device. And there are school districts that do this, that limit the dictionary so that those words are not available on the device. And that the cool part is when you do that, they're not available in anything. It's not just a Sphero Edu thing. They're not available in anything. So that's an option from an IT side of things. Some people are just like, classroom management, like just make sure your kids aren't doing that and they know it's not appropriate, and moving on. Cool part is it's whatever you type into here. It can be pretty much any length. I had an educator test this in an on-site professional development this past summer. I was working at the school district of Philadelphia, and I had an educator that decided he was going to copy and paste the lyrics to an entire 4.5-minute song and post and copy and pasted them into there, and Sphero Edu processed that, and the programming device read all 4.5 minutes of the song, although it took a lot longer to read it than it did to sing it. So It's whatever you put into here. Also, to kind of expand on this while we're talking about it, if you go under the operators category, there's something here called build string. And this particular block can fit inside of this speak block. Notice the rectangular shape and the rectangular shape, right? You can actually drop this into here, and then you can combine multiple things. So if I hit the little pencil, this is going to start with text that we type in. I can add things like a number. I can add in things like a true or a false or a color, right? And I can drop all those different kinds of things into here. So say I wanted to do text, then read a sensor, and then more text. I would have a setup like this, and you can customize it any way you want, right? And then I could go under sensors, and I could drop in whatever it is that I'm looking for. So if I'm thinking about what I have up here to draw this shape, I can have it speak my heading. So I can say the heading is, it'll speak the number, and you can type something in right after this, right? Boom, and it's ready to go, right? So the cool part about this is I can drop that in. Every time it loops, it's going to give me that speak portion for my heading every time it changes. So you can really do some cool dynamic things.
If they're learning fractions or angle, or the, percentages or whatever, I could see that.
Yeah.
Being a cool way to show learning.
Yeah, and you can do some really.
You at the close of the project, so you wouldn't let them hit their button, but just do teleport all players out.
I know we're getting short on time, and Ms. Nelson had put a question in the chat, and I want to make sure she gets a chance to get that one addressed. Ms. Nelson, do you want to come off mute and repeat your question, or maybe Brad can just read it from the chat? You guys?
I can unmute. I just was asking with that communication activity, would it be one group that's using two robots and trying to do both pieces, or would it be like two groups kind of working together to get the robots to communicate?
Yeah, great question. So this really depends on kind of class size for you. So if you're we always encourage pair programming. So where it's two students to kind of one robot, and then doing that. But generally speaking, the infrared communications probably isn't like a week one kind of activity, right? This is kind of pushing a little further down the road. They've already learned how to get the robot moving. They've learned about lights and sounds and things like that. Now we're going a little further. So at this point, you could branch out and say, all right, the two of you, this group, each grab a robot, right? And then they each have a programming device. You two are going to work together to make one robot communicate with the other, right? Do whatever that activity is. Or if you have maybe a really large class and that's not an option, right? You could say, okay, you're a group of two. You're going to have your robot send a message to this other group of two and have them pair program that together. Right. So it really depends on that class size and what you feel is a good fit for your particular environment. But that's a great question.
And it depends on the number of communication channels. There's only what, 9? Is that, or 10?
There's 8. Yep, there's 8 channels. Now the other part of that is, remember that it's infrared. So if you have a way to divide them so that the robots can't see each other, not a problem. Now you can do this. And the robots won't communicate accidentally with something else because of that. So you could send 2 groups out in the hall right outside of the classroom and be like, here, do this right here. These are your channels to work with. Your other groups are in here. They have these channels to work with. So now you can repeat channels just by having them in slightly separate locations.
That's helpful. So even if you did maybe 2 halves of the room, as long as they're not, how far do you think those infrared signals?
Yeah. So there's a lot that can affect that. The lighting in the room is one of them. The any other things that are in the way. It's like if I crank it up to 64, it's gonna make it to the other side of the room, right? So drop that signal power, that intensity down. Now it's not gonna make it to the next group, right? Yeah. Definitely great. Well, thank you everyone for jumping on here and bearing with me. I'm in a different environment, so it's a little tough to juggle some things here. But I appreciate everyone jumping on here today, and hopefully you're ready to start getting the robots communicating with each other.
Before you guys jump out, don't forget to grab that attendance link. I dropped it in the chat. So make sure that you click on that before you pop out of this meeting. And then we have 9 minutes before session number 2 begins at 10:30. So check your schedule, make sure you know where you want to go and how to get there and everything. And then you got 10 minutes to use the restroom, get a cup of coffee, water, stretch your legs, all that kind of stuff. And then, yeah, we'll see you back at 10:30. Thanks, guys. Thank you, Brad.
Thank you, everyone.
There's kind of a collection of student notes.